Okay, so far we have seen different molecular or functional groups that have different chemical properties. As you know, the different functional groups doesn't only affect the chemical property, but also their physical property, like melting point, boiling point, solubility, and all that. So as a review of intermolecular forces, electrostatic force is mainly in ionic compounds. So the property where you have a very strong interaction in molecular forces is electrostatic force, which is very characteristics of ionic compounds. But here in our course for organic chemistry, most of the forces that we will be dealing with would be like van der Waals forces, dipole-dipole forces, and hydrogen bonding. These are the main intermolecular forces that are responsible for various physical properties. So these physical properties are differences are a result of functional group. For example, if you just look at here, this is 1, 2, 3, a pentane compound. Its boiling point is only 36 degrees centigrade. If you just look at here, almost one carbon lace, which is normal butanol, it has a boiling point of 118 degrees centigrade. So if you just look at here, this is all sp3 hybridized carbon, and no functional group that is reactive. The only force that can be present in this kind of compound, in alkane, this is an alkane compound, this is alkane. Most of the forces are a very weak van der Waals forces. So the molecules would have only van der Waals forces, that is a transiently formed electrostatic interaction, not very full charged electrostatic interaction, but transiently formed charges that are built up in the molecule itself. So it's very weak. Van der Waals forces operates in alkanes. Here, as you see, van der Waals forces could exist in this molecule, but additionally, you have this OH group that can make hydrogen bonding. Hydrogen bonding. So the hydrogen bond, which is a relatively higher interaction, makes the molecule to boil at high temperature. So the boiling point is 118 degrees Celsius. So alkane versus alcohol. So the functional group for this is an alcohol. Remember, the alcohol functional group makes a hydrogen bond type interaction between itself. So when you say intermolecular forces, it's a force between the same molecule, within the same molecule. If you just look at here, this compound right here, this is an alkyl chloride functional group, alkyl halide. So the boiling point is 78 degrees. So if you are asked what kind of intermolecular force can exist in this one, you can just say a dipole-dipole interaction could exist. So this would be dipole-dipole because of the dipoles that can be formed in this molecule. In the next section, I will show you graphically how it looks like. As you see here, this molecule is a functional group of aldehyde. The aldehyde could have a very weak dipole-dipole interaction, not hydrogen bonding, but just a dipole-dipole interaction together with, obviously, all of them can have van der Waals forces. So in this section, what I was just outlining here was a general idea of physical properties like melting point, boiling point, that would be affected by the presence of different intermolecular forces. The intermolecular forces that are present in most organic compounds are van der Waals forces, dipole-dipole forces, and hydrogen bonding. These are very common in organic compounds. These are also dependent on how strong they are, would be depending upon what kind of functional group you have in the molecule. Here is alkyl halide, here you have alcohol, here you have aldehyde. This is an aldehyde functional group. Here it is this straight chain alkane. So different functional groups would have different kind of intermolecular forces. So in the next section, I'll show you each one of them, how they display the intermolecular forces so that the molecule would boil at higher temperature or boils at a very low temperature in alkanes. Okay, here I have outlined compounds with different functional groups and also with different isomers of compounds that would be affected by their intermolecular forces and having different boiling points. So as an example, I just took a straight chain normal butane. This is called normal butane because it's a straight chain. Here you have a branched butane, isobutane. It's only 4 carbons. It's 4 carbons. So most of the intermolecular force that is present in unfunctionalized or those which are just alkanes is van der Waals forces. Remember this, for all alkanes, as we have already discussed, the major or the most important intermolecular force is a van der Waals force. So if they are both 4 carbon compound, which this is a butane, normal butane, this is isobutane, a branched butane, branched because the way it's constituted is different as opposed to this one, even though they have the same molecular formula. So the boiling point here is -1 degree Celsius. The boiling point for this compound is -11.7 degrees. Obviously, this is much higher boiling point than this one. So the reason being, the intermolecular force is the force between itself. For example, if you have another molecule of this, CH3, CH2, CH3, CH3, the intermolecular force is between these two. The more long they are, long chain, the van der Waals forces is much more. What this shows us is if you have a straight chain compound, the straight chain would develop a transient charge on its surface. Those charges are not stable. They are just transient. So if another molecule comes on top of this, that transient charge would make an electrostatic interaction with the other one. Therefore, that interaction, which is called the van der Waals forces, is due to a transient, which is not a stable or a strong permanent charge that would create an intermolecular force known as van der Waals forces. So van der Waals forces would be very higher in a straight chain. So this is long chain, but this one is branched. So in the long chain versus branched one, the branched one is like a sphere. So there is no much charge that would be created between another molecule to be of significant energy into the molecule. So the van der Waals forces in the branched system is much lower. So by just looking at molecule structure, by just looking how many chains that particular compound has, you could be able to predict the boiling point. You don't have to know the exact numbers, but qualitatively you could tell if somebody asks you, what is the boiling point difference between this and this one? Obviously, they have the same number of carbons, 4 carbons, and basically from what we have just discussed now, due to the van der Waals forces in a very long chain ones, if you have a straight chain that has a more van der Waals forces in between them, therefore you have higher boiling point. Here, the branched one doesn't have much of van der Waals forces, therefore it has lower boiling point. So the next kind of force, intermolecular force, which is due to the functional group of having a heteroatom like oxygen, whether it is in a double bond or in a single bond. The intermolecular force comes because of the interaction between, for example, if you have one molecule here, another molecule of the same, another molecule. Remember, we have already said that the dipole moment on this is like that, but the charge is partial positive charge on carbon, partial negative charge on oxygen. Therefore, the other molecule flips itself and aligns itself between this oxygen and the carbon. So in the intermolecular force, they attract each other within the same molecule. And here also, if you have the sigma plus here, sigma minus, this one would create some kind of intermolecular force. That is called a dipole-dipole interaction or dipole-dipole force. The dipole-dipole force is between two dipoles of sigma plus and sigma minus. So if you have such charge that could be generated because of having a heteroatom as a functional group, that would have a dipole-dipole force. The dipole-dipole force is much higher than van der Waals forces. So this compound, such compounds would have, obviously for the same number of carbon, would have a higher boiling point. So dipole-dipole interaction is strong. So it is, as a review, remember, it is due to dipole moment. A dipole-dipole interaction is created between the same molecule because of the partial positive charge, partial negative charge. The partial positive charge interacts with partial negative charge of the other molecule, and the partial negative charge of the other molecule would interact with the other molecule of charge positive. That is almost an electrostatic kind of interaction that can be developed. Since they are not full charges of plus and minus, we cannot call them like ionic electrostatic, but it is due to only a partial charge because of the electronegativity difference between this carbon, that oxygen, this carbon, and that oxygen, this carbon, and that oxygen. That is called a dipole-dipole interaction. Here I have two compounds. I'm comparing the same, almost the same structure, but one is alcohol. This is alcohol functional group, and here this is an ether functional group. So if you just look at here, the boiling point is 78.4 for the alcohol. Here boiling point for the ether is 34.6. The main reason why this difference happens is this compound right here, the alcohol, can make hydrogen bonding. So the intermolecular force that's operating in the alcohol is mainly of hydrogen bonding. The hydrogen bonding is through this oxygen and another hydrogen of the other molecule. Say, for example, if you have this hydrogen right there, let's say this, it would interact with another oxygen from another molecule, another hydrogen, oxygen, CH2, CH2, CH3. No, it's just two carbons. So I'll just leave this as CH3. So if you just look at here, this is a hydrogen bond that can be formed between the two molecules. So the third molecule, it continues, the chain continues. So hydrogen bonding always happens between oxygen or electronegative atom, which is containing a hydrogen, that can make a hydrogen bond with another molecule. So for a hydrogen bond to happen, you should have always a hydrogen that is attached to electronegative atom like oxygen. It could be nitrogen, it could be other kind like like HF, hydrofluoric acid. So you should have always a hydrogen that is attached to an electronegative atom so that it would make the hydrogen bond between another molecule. That's why the alcohol, which is actually ethanol, has a higher boiling point than the diethyl ether. This is called diethyl ether, which doesn't have, the oxygen doesn't have hydrogen directly attached to it. That's why it doesn't form a hydrogen bond. The ether cannot form hydrogen bond because the oxygen right here at the center, the bridging oxygen, obviously doesn't have hydrogen that can make a hydrogen bonding. So hydrogen bond is a strong bonding that would create high intermolecular force so that the boiling point becomes 78.4 for ethanol. So these are some of the reviews where you have van der Waals forces exemplified by these two examples. A dipole-dipole is interaction such as this, and a difference in boiling point between a diethyl ether and ethanol due to the presence of hydrogen bond in the alcohol but not in the ether.